All right, so in this section, we are going to take a look at all of the vocabulary that we have worked with in Module 8, Lesson 1, and apply it to 3 different statistical scenarios. So during this module, you learned about samples and how we use samples to make inferences or conclusions about the population. In the next 3 scenarios, you'll be identifying what is the sample, what is the population, what is the parameter. Remember, the parameter is any number that's associated with the population. What is the statistic? Remember that that is any number that is associated with your sample, and whether or not we're dealing with an experiment or an observation. We'll then make a decision on whether or not we can make an inference or conclusion about the population that we have defined. So let's take a look at our first scenario. So in our first scenario, we want to know, does having a Bluetooth in the car reading text messages decrease driver distractions from the road? Investigators randomly recruited 80 subjects to participate in an experiment. They had a driving simulator that was equipped with Bluetooth that read text messages every time they were received. The researchers are measuring how many times the drivers took their eyes off the road. 40 participants completed the drive with a cell phone in the car, and the other 40 participants completed the drive while having their incoming text messages read to them via Bluetooth. The route, driving conditions, and traffic flow was the same for both groups. At the end of the drive, the participants that had their text messages read to them looked away from the road an average of 10 times. The participants that had their cell phone with them but did not have their text messages read to them looked away from the road an average of 25 times. We want to know, does having their text messages read to them decrease their distractions? All right, so we're not actually going to answer that question, but we're going to take a look at what is the population, the sample, the parameter, sample statistics. What's our control or placebo group? Was this an observation or experiment? And can we have inference for the population? So number 1, what is the population? It's all drivers with cell phones, because where did the sample come from? They randomly recruited 80 subjects to participate in an experiment, and we are only talking about people with cell phones. This would not apply to people that don't have cell phones, because that would not distract them in the car. What was our sample? It's important to note here that they were randomly chosen, so 80 randomly chosen subjects. The parameter is we're actually not given any numbers associated with the population. But we could say the parameter of interest, what number are we interested in, is saying, do text messages decrease their distractions? So the number of text messages read, if they are given a Bluetooth or not given the Bluetooth. What were our sample statistics? So it's the average number of times they looked away from the road. So this would be X bar, or our sample mean, which was 10 for the group that had the text messages read to them and 25 for the group that did not have the text messages read to them. In this case, we do not have a placebo, but we do have a control group. So the control group was the group that did not have their text messages read to them. This was the control group because they did not have a treatment applied to them. Was this an observation or an experiment? This was an experiment because we applied the treatment to them. We put them into groups of either having their text messages read to them or not. And the question is, can we make an inference for the population? Well, our population was all drivers with cell phones. So in this case, we can make an inference for the population of drivers with cell phones because the subjects were randomly chosen. Since they were randomly chosen, that means that my sample is going to be a good mini population. If I have a good mini population, I can make inference or conclusions about the population. Let's take a look at our second scenario. So in our second scenario, we're taking a look at cardiologists at Duke Medical School. They want to test whether or not chocolate affected blood flow and lowered blood pressure. They decided to test this theory using a 4-ounce bar of dark chocolate, 98% cacao, and a 4-ounce bar of fake chocolate. The researchers recruited 20 healthy men and women aged 50 to 60 for the study. On day 1, all subjects had their blood flow and blood pressure taken. On day 1, each subject ate the dark chocolate and their blood flow measured and their blood pressure was taken. On day 2, the researchers did the same thing, only with fake chocolate. The subjects had no chocolate outside the study, and the researchers and subjects will not know whether or not they ate the real or the fake chocolate. At the end of the study, the researchers concluded that blood flow was increased by 25% and that blood pressure was reduced by 5%. All right, so what is the population of interest that we're looking at here? It is specifically healthy men and women aged 50 to 60. Well, how did I decide that? Because the sample that was chosen was only healthy men and women aged 50 to 60. I cannot use this study to look at a population of unhealthy men and women because they were not included in the study. What was the sample? It was 20 healthy men and women. Now, keep in mind here that this does not say that they were randomly chosen. So that's going to be important later on. The parameter, we were not given any specific number associated with the population percentage that was increased or decreased, but the population percentage of blood flow that was increased and population percentage of blood pressure that was reduced is the parameter of interest that we're looking at. So what were our sample statistics? Now I have defined two sample statistics. Why did I make this P1? Because I have one proportion that I'm looking at, and then I have a second proportion that I'm looking at. So since I have two different proportions that I'm looking at, I'm going to define the first one to be P1. Notice how it says percent increase in blood flow, and P2 is the percent decrease in blood pressure. So when I use my sample statistics or my sample proportions, notice how I have P hat here. Okay, so I have P hat, and with the 1 tells me that that's talking about blood flow. So I had a 25% increase in blood flow, and P2 is going to say that's looking at blood pressure. Since that says decrease, that means I have a 5% decrease in blood pressure. Notice how I have the hats to show that that's from the sample and not the population. What is the control group or the placebo? So the placebo here was actually the fake chocolate. So we did have something that looked exactly the same as the treatment, tasted exactly the same, but was not the same. Was this an observation or an experiment? In this case, this was an experiment because they had a treatment applied to them. The treatment was the dark chocolate or the placebo that was not the dark chocolate, which was actually the control group. So the treatment was the dark chocolate. What inference for the population can I make here? We can say for the population of healthy 50 to 60-year-old men and women, I can use this conclusion for, but I need to actually be really careful because it doesn't say that they were randomly chosen. So since they weren't randomly chosen, I might need to redo this experiment with 20 randomly chosen men and women to make sure that I can make inference for the population. All right, let's take a look at the last scenario. So does the class size matter in grade performance for high school math? Well, students do better on their end of course exams if they're in smaller classes. Researchers observed 2 Math 3 courses at Langley High School. One had 15 students and the other had 30 students. At the end of the school year, the average on the end of course for the class of size 15 was 85% and the class with size 30 was 75%. So we want to decide whether or not the small class sizes helped or did not help with the end of course exam. So what is the population here? So the population here is the Math 3 courses at Langley High School. So be careful, it's not all Math 3 courses across North Carolina. The sample was only taken from this high school, so we cannot use the results for any other high school. The sample here was 2 classes at Langley High School. What is the parameter? Okay, there's no parameter given, but the parameter of interest is we're seeing, does class size help with their end of course exam? So the percentage on their end of course exams is the parameter that we're looking at. What sample statistics were given? We were given the average end of course exam score from the class of size 15 and the class of size 30. Keep in mind the class size is not actually going to be the sample statistic, it is the percentage. So notice how this says X bar, so that's going to tell us that that is from a sample and not from the population. Okay, the 85% or 0.85. So that was your mean of your test score for the first class size of size 15. And X bar 2, so that tells us, okay, this is the second class. X bar tells us that's from a sample. And that average on the end of course of exam was 75%. Okay, what was the control group or the placebo? The control group was the larger class size to compare the smaller class size to. Was this an observation or an experiment? In this case, this was actually an observation. They didn't have any treatment applied to them. They just observed their scores. The researchers also did not create the large or the small class sizes. This could have been an experiment if they had made the class sizes from the beginning and randomly assigned students to class size 15 and class size 30. But since this was already set up, that's what makes it an observation instead of an experiment. And then finally, since it's an observation, they did not have any treatment applied to them. They just observed their scores. So the researchers did not create the large or small class sizes. So the question is now, can I use this as inference for the population? So that since this was only completed at Langley High School, I can only use my results to make conclusions about Langley High School. But since they were not randomly chosen classes at Langley High School, I just have to be careful about whether or not I can make a conclusion about the population of class sizes at Langley High School and whether or not the class sizes help to increase their test scores if they're smaller. Take a minute and try the You Try video.